inequality, what's different about an inequality from an equation?
You have to shade.
You have to shade. What else can have be different?
Dotted line. Solid
You might have a dotted line or a solid line. So we graphed inequalities in the last chapter. And you had to remember dotted line or solid line, and you have to shade. Well, think about a system of inequalities. It's not going to just be shading both of them, but it's where the shading overlaps, because we're trying to say what's true for both of them. So this is where, especially if you are an ink pen user, you need to be really careful, because otherwise your graph might just end up looking like a big scribbled mess, as we do these. So step 1, graph each inequality, shading the correct area. Step 2, identify the region that's shaded for all the inequalities, the overlap of the shading. So I started with one that's in slope-intercept form, just so you could see what's happening. But then again, just like everything we've done, most of the time they're not going to be in slope-intercept form. You got to be able to get y by itself. So I don't shade until the end when I'm doing this on paper. I'm going to shade this one and just overlap because I have markers in different colors and we can see this. But I'll show you what I do if I was doing this on paper. All right, so step 1, 2x minus 3. You should feel like a pro at this now of like, I love graphing in slope-intercept form.
Go down 3.
Because my y-intercept is negative 3.
Up 2 over 1.
And this is my slope, so I say up 2 over 1. Up
Over
2
1.
over 1. Up 2 over 1.
Yeah, all's name.
Is that going to be a solid line or a dotted line? If there's a line underneath it, it's a solid line. So I'm going to make a solid line through those points. Oh, that's not very straight. That's good. Questions about that? And then remember, the great thing about linear equations is when you're shading, it kind of makes sense. This is greater than, so what makes sense? That we would shade above that line or we would shade below that line? Above. And so if you don't do this yet if you don't want to have a messy paper, but if it was just this one, we would say it's everything up here. And I have different colors. So if you don't want to make a mess of your paper, you could just do this. This is what I do sometimes. I just make a little scribble down here. Couldn't say that word. To remind myself I'm going to shade on that size line. And now I'm going to change colors. And I'm going to graph negative x plus 2. That's my y-intercept on this one.
2.
So up on the y-axis at 2, I'm going to make a point. And my slope is negative 1. So you have to go negative one way. So if you go down 1, you're going to go over positive 1. Or if you go up 1, you would go back 1. Should this one be a solid line or a dotted line? Dotted because it's not included. So the big difference here is that we're not looking for the point of intersection, we're looking for the shading intersection. So on this dotted line, because it's less than, which way would I shade for this blue line? It would be everything underneath it. So again, it's really nice because I have different colors here that I can shade like this and see how it looks messy.
Oh, I see.
The answer is where are they both shaded? So it's really nice to see it in color here, because it would be the section that has both red and blue shaded. And so I could be really creative here. Let's do the creative pen. And I could say it would be everything that's below the blue line that's also above the red line, which would be this whole section right here. And that's the only part you have to shade. If you're going to do like I did, you need to make sure the part that's the answer that like you shade in really dark, or that you show that it like crisscrosses or something. Show me that you know that this is the section. And I'll do the next one like it was my paper, and I'll show you what I would do.
What if we have pins? Can we just like tell me what the thing is?
Like this part, right?
Yeah.
Right. So like you can shade the other parts lightly.
Like that?
Yeah. And so you could shade the other parts lightly and then shade the actual answer dark, and then I would know that's the answer. Vague memories of this? Yeah. Just like we can have no solution with a system of equations, we also can have no solution on linear equations if we had two lines that their shading didn't overlap. Like that could be a no solution. Can't think of a way that we would have the same, like infinitely many, like where it would be the whole graph shaded. Can't think of a line that would shade the whole graph, but no solution could happen on this. Okay, so take a minute. Oh, look, these are already in slope intercept form too. I'm so nice. So take a minute on this. If you haven't already, graph these two and think about where the shading would be. Are they going to overlap? Where would the overlapping be? And again, they're already in slope intercept form for you. Well, let's see. If it's which one's this one? This one's this one. So greater than would be which way on that way. And then this one would be less than, right? Right. Think about whether your lines would be dotted or solid. Oh. Here's something right with.
I got it.
Better to ask for something right with than sit there without anything to do. What do you know about these two equations in this book? They're the same, right? So what kind of line should these be when you graph them? Parallel. So something's going wrong there, right? Alright, I'm gonna graph mine. Line intercept. Oh, I forgot I have this big giant thing going on.
No, that's cool. Keep it.
No, I can't make a line like that.
Don't let it tell you what you can't
Plus 1. So my y-intercept is 1, and my slope is negative 3/4. So it doesn't matter which way you go negative, as long as one way is negative and one way is positive. So I could go down 3 for the negative 3, and then over positive 4. But you could also go up positive 3 and back a negative 4. I think if you're someone that struggles with graphing, always take a minute and see if your slope matches what you drew. Like this is a negative slope, so it should kind of look like this line's going down as I graph it. It's really easy to mess that up. And I just paused for a minute as I drew that line because I wanted to check to see if it was solid or dotted. A line underneath it means it's solid. So think about this one. This one's greater than. So which way would you shade on this? You would shade above it. So Caitlin says she's just going to do hers lightly and then go back and overlap it. That works. Sometimes what I do is I just do this. Like I just make a few marks on here to know that I'm shading this way if I don't want to make the whole thing. And then this one has a y-intercept of negative 2, and it's the same slope. So hopefully we remember that same slope lines are parallel. So this should be a parallel line of I could go down 3 over 4, or I could go up 3 and back 4. Also a solid line. That's not a very straight line, but that's okay. And since this one is less than, which way are you shading? So where do the shadings overlap? They don't overlap. So the answer to this is if they never overlap, the answer here is no solution.
Unless the graph looks cool.
Now definitely there could have been a solution here if we just changed some of these signs. So don't assume that parallel lines are always going to have an answer of no solution, because it could have been, if we would have just switched these two signs, it would have been everything in the middle. Or if the bottom one was also greater than, it would have just been everything above that line. So this is an example of no solution, but some parallel lines will have a solution. So make sure you actually check the shading there.
Is that how you would want us to answer it? Like everything is greater? Like if the bottom one were a greater solution as well?
If this one was greater than, you would just, if this one was greater than, then your answer would have been all of this. Like it would have been everything above that line.
I think he's referring more towards like how you would write it without shading. So like on that you
Well,
wrote,
no, like
wrote a
what
solution.
would our answer be? Like would you tell by that? Just by
Yes, so like here's the difference between equations and inequality. With equations, you have to tell me the point where they cross. With an inequality, the answer is the shaded part of your graph. So the only time you have to write anything on an inequality is if the answer is no solution, because there isn't a place. This one, your answer is the shading on your graph, because like every point in here is a solution, so you can't list all those out. So that's why like the graph is your answer. Does that answer your question? Okay.
Go back to the other one.
So this is something that you did in Algebra 1, but then there's this next step, okay? So this next step kind of leads us to where we're going to go tomorrow, in that they're going to give you more than 2 equations, and they're going to ask you to find the shape where all the overlapping happens. So, that's my last example. Are you okay with this? So it says, find the coordinates of the vertices of the figure formed by these 3 equations. So notice 1, 2, 3. What kind of shape could I make if I have 3 lines? A triangle. If I had 4 lines, it could be any 4-sided shape, which generically we say a quadrilateral. So we need to graph those and be really careful with our shading to find the overlap there. Also notice, none of these are in slope-intercept form. Sometimes they will be, sometimes they won't be, but our first 2 examples were in slope-intercept form. So the first thing you have to do before you can graph these is you have to put them in slope-intercept form. So I'll start the first one, and then I'm going to give you a minute to do the other 2. But remember, you have to get y by itself first. So in that first one, I'm just going to subtract 2x. So I would have negative y is greater than or equal to, and again, I'm always going to put my 2x first. It's a negative 2x and it's a negative 1. Watch those signs. That's what messes people up the most. The other thing that messes people up is they forget that this negative is with the y, right? That's like a negative 1. So to get y all by itself, we have to go through and divide everything by negative 1. But we're dealing with inequalities here. So what do we have to remember when we divide by a negative? We have to flip that sign, right? If you forget to flip your sign, it's going to get messed up. So I think we should have y is less than or equal to negative 2 divided by negative 1 is just positive 2. Negative 1 divided by negative 1 is positive 1. If you are really bad with negatives, you need to use a calculator. Don't miss questions because you don't know how to divide with negatives. Then you could graph it, all right? But take a minute, if you haven't already, before you graph these, and get y by itself in both of those, and then let's make sure that we all agree before you start graphing, especially if you use it. Only if you multiply or divide by negative. So if you just subtract, that doesn't change your sign. Only if you're dividing by negative. Think you have something to write with? Ask me for something to write with. There is a container of pencils here. If you have nothing to write with when you come into my classroom, you should come up here and get a pencil. And the polite thing would be to put it back at the end of the hour, so then you have one for tomorrow if you don't have a pencil. But don't sit here and not do anything when you could just ask for a pencil.
Are you okay?
No. What are you doing?
I'm getting ready to do my math. That's what I'm doing.
I've resorted to just yelling at you guys all the time. That's my new strategy in life. I'm not really yelling. That's pretend yelling, right? That's just been sweet. You'll know when I'm really yelling.
Yeah.
Are you graphing, Alex? You're gonna lose your computer privileges.
He's sitting back here talking to more stuff. I'm going to be like,
What happened to the notes, Alex? I got the notes out. Oh, they probably heard me yelling. They're calling to yell at me. Hello, Miss Dixon's room. Okay. Okay. Can I send them in like 5 minutes? Or I have to send them right this second? Okay. Okay, thank you. We gotta go. We gotta be fast. Alright, so if I solve this, I would subtract x over and get negative x plus 4. And then I'm going to divide everything by 4. So my third equation, I think, I'm going to write it over here. I got y is greater than or equal to negative 1/4 x, because it was a negative and I'm dividing by 4, and then 4 divided by 4 is 1. So the very first thing that you should look for is, did you get all your equations solved for y correctly?
Yeah, if you put like on the negative x for the slope and then put a y in front of the x.
Definitely. Okay. So then you just have to graph correctly and hope that they cross at a nice point. Otherwise, you have to do some algebra. But for the first one, 2x plus 1, that would be a y-intercept of 1 and a slope of up 2 over 1, up 2 over 1, down to back 1. And I'm going to try to make as nice lines as I can here. Thank goodness it was a solid line because I just did it without checking. Again, this is where I like to just do the little bit of, this is everything below this line, so I'm not going to make a big giant mess on my paper, but less than, I know that that would be like shading in this direction, so that's what I do. It's your choice of what you want to do. This one is negative x plus 4, so that's a y-intercept of 4. And a slope of negative 1, so that would be down 1 over 1, down 1 over 1. It's really nice when I can see they cross already. So that one's also a solid line. And it's less than, so less than means below. So that would be like everything looking like this. If it was just 2 equations, then our answer would be this little section down here, right? Questions on where I'm getting that? So then my last one has a y-intercept of 1. Oh, look, I already have one with a y-intercept of 1. That's good news. And it has a slope of negative 1/4. So that means down 1 over 4. Down 1 over 4. Why does that look so weird? The one we haven't graphed. Down 1 over 4. Down 1. 1, 2, 3. Oh, there we go. Also a solid line. What some people do on this is they don't even look for the shading, they just look for the triangle that's formed. Do you see that triangle that's formed? So what some people do is they're like, I don't even need to think about the shading because I'm going to be able to find that triangle. This would be greater than, so it would be everything like this. Here is my shape that I formed. The question says, give the coordinates of the vertices, which means they want you to give the points. The vertices are like the corners of that graph. So your answer here would be, that would be the point 0, 1. 1, 2, 3, 4. That would be the point 4, 0. And then this one is that 1, 3. Over 1 up 3. That's the other one there. Tomorrow we're going to do something called linear programming, and it builds off of this, of being able to find a closed shape and then finding max and min values. So if you get this today, then you'll be pretty good for tomorrow.
This is easy.
Good. So if you're a senior, when you get this paper, you need to go down to get your cap and gown stuff worked out. Just kidding. If you're a senior that leaves for area 30, you need to go get your cap and gown worked out. Up there. If you're not a senior who leaves for area 30 that needs to leave right now, you have 10 minutes. The first, I can't number. I wrote 1, 2, 3, 3, 4. The first 5 problems, which number? There's 2 number 3s. You're just graphing, finding where they overlap, putting in slope-intercept form. And then 5 and 6 are like what we just did. All right? So if you are really bad at slope-intercept form, if you want to go through first and put them in slope-intercept form and have me look at them before you start graphing, I'll be happy to do that. This is due tomorrow, and then we'll have a homework quiz over this as well. Okay, so work on this. Ask me questions if you have it. Stop all this recording. Oh, look, all that yelling is on the recording you can watch.
Yay.